into a series of dry years, an extended run of dry years, then all of this is, we'd have to rethink this. And there is the potential for long-term droughts, particularly in western Kansas. Certainly the historical record that has been compiled now indicates that there were some multi-year and even a couple decade-long droughts in western Kansas, and that would of course be very difficult to confront. But I just wanted to give everyone a sense of what, under current climatic conditions, what would be required on average to stabilize water levels. Now, obviously, if we're going to try to reduce pumping, that would have to be on a relatively large scale of area. It'd have to be implemented over a relatively large scale to make a significant impact on decline rates. And such large scale reductions require a management framework that makes them possible. Now, in 2012, the Kansas Legislature passed a bill that allowed a new option for groundwater management in Kansas, the Local Enhanced Management Area, or LEMA. And the idea for the LEMA is you have stakeholder-driven or locally generated management plans. So this would be producer-driven management plans. They agree to moving forward with a certain level of pumping reductions, and then the regulatory agency comes in and makes sure everybody plays by the agreed upon rules. So locally generated, supported by the regulatory oversight. And back in 2013, the first of these was established in a 99 square mile area mainly in Sheridan County, the Sheridan 6 LEMA. The success of that area led to the development of the LEMA for the entire groundwater management district. They're number 4 in northwestern Kansas in 2018. And then most recently in west central Kansas, Wichita County LEMA has been approved, and that will get started this year, is my understanding. And so we've begun to see the implementation of this LEMA framework, and I think there's a lot of potential here in terms of our scientific analysis of conditions. Now, I'm not an ag economist, so I can't really comment on how effective it's been in terms, these LEMAs have been in terms of the producer's income. However, in Kansas State, ag economist Bill Golden has done an initial assessment of the Sheridan 6 LEMA, and his finding was that producers who participated in the LEMA did just as well. Their bottom lines did just as well as those outside. But again, I'm not qualified to comment on that. But in terms of hydrologically, there's 2 factors that you want to achieve in a LEMA. First, you want to be able to reduce the rate of pumping. So I had a slide here that I just wanted to illustrate how they've done in that Sheridan 6 LEMA since the initiation. And so what I've got here is this is a plotting framework that we developed at the Kansas Geological Survey to help folks assess if water conservation has actually been achieved through various measures. So this is annual water use on the y-axis there, and thousands of acre feet. This is annual precipitation. We could also use irrigation season precipitation as well. The blues are years prior to the establishment of the LEMA, from 2002 to 2012, and the reds are after the establishment of the LEMA, 2013 to 2019. We have yet to get the 2020 pumping data. So a couple of things I wanted to bring to the committee's attention. One, clearly, for the same precipitation, they're pumping considerably less water. and we figure it's about 30%. Their goal was 20% reduction, and in this first period, they've achieved about 30. Now, you have to qualify that because you'll see from this plot that they have not really dealt with the dry conditions that they faced in the period prior to the Lima. So there's still some questions to be answered about how the Lima will perform during dry conditions. But certainly during average to wet conditions, they've been able to reduce water use significantly. And ultimately, the key metric to look at hydrologically for a Lima is how has it impacted the decline rate. And in the Sheridan 6 Lima, the decline rate has decreased by 69% since the onset of the Lima. So they've not only reduced the pumping, but they've also significantly reduced the decline rate. However, though, they still, on average, are declining each year. So this is not sustainability, but this is significantly extending the lifespan of the aquifer. But again, the ultimate test will be how it performs under drier conditions. And obviously 2020 was a drier year, and so it'll be interesting to see when we get all the data in for 2020 how it did. So anyway, I just wanted to give the committee a quick overview of some of the things happening in the High Plains Aquifer. And now I wanted to quickly turn my attention so that the members of the committee in the East don't feel left out and talk about the Kansas River Alluvial Aquifer, because this is a major aquifer system in northeastern Kansas. And I think most people would agree that the Kansas River Corridor is projected to continue to be a major area of population and economic expansion. In the coming decades, groundwater is going to be needed to help fuel that expansion. And the key question is, how does the Kansas River and the underlying aquifer interact? And how will, say, increased pumping in the aquifer impact the river? And so that's a major objective of our work now, is try to develop a better understanding of the relationship to the aquifer to the Kansas River. And we're doing that with another network of index wells that we've started in late summer of 2017, and we have a series of wells, now 11 in number, from basically west of Manhattan to just east of the junction with the Missouri and Kansas City area. And we're recording water level positions every hour. It's sent out via telemetry, available on the KGS website in real time. And here on the right, just as an example of one of the wells, then the yellow there, then you've got the little canister there on top of the steel pole is the telemetry unit. And that's one in Shawnee County there. So this is just kind of getting rolling, this project. We have been impacted a little bit by the pandemic in terms of our ability to get out in the field. We have about another 5 wells that we'd like to get in before the summer to fill in some gaps, say at St. Mary's and Lecompton. We're getting some transects across the floodplain. One you can see near Lawrence. We've already got 2 of the wells in place there. We're going to do a similar transit close to Wamego there, going off the WBO1 well. So this is an area that we're going to be working on extensively in the next few years to develop an understanding. And the idea is that we're going to construct a model of the relationship between the aquifer and the river, and so the state can have a tool to work with in terms of assessing what the future holds for this area with increased pumping and economic activity. So I just wanted to give you a quick glimpse of that. And one other thing, and then I'll shut up and take questions, is I wanted to mention an area on water quality, and just in passing, and remember early on I talked about that one area in south central Kansas where you've got the natural salt water coming up from depth into the aquifer. But I wanted to talk about another area. And here I return to this percent change in aquifer thickness map, and notice the area with the white ellipse there. This is the upper reaches of the Arkansas River in the state, from the state line to just east of Garden City. Now, this is an area that water quality is beginning to be a real concern. Now, in terms of water quantity, they're in pretty good shape. If you look at this map, see if I get this cursor around Lakin, notice that the colors here are very light, indicating there's been relatively little change in the aquifer thickness since the onset of widespread pumping for irrigated agriculture. The reason is the river is recharging the aquifer. Again, as I said earlier, we've drawn down the water table, and so the river now feeds the aquifer. In fact, all of the Arkansas River flow that comes across at Colorado goes into the aquifer, either directly through the bottom of the river channel or distributed in the irrigation networks there to the west of irrigation channels networks there to the west of Garden City. Virtually no water gets past Garden City. I would say since, I would say 15 to 20 years, there hasn't been any water getting past Garden City. And basically, you've got a dry channel from Garden City, actually upstream from Garden City all the way to Larned, when the Pawnee comes in at Larned. So all the water coming across in the Colorado line is going into the aquifer. What's the problem? The problem is the quality of that water is not very good. And what I've got here is just to give you an idea of that quality. So I've got two quantities I'm plotting here. On the upper plot, that's sulfate, and in lower plot, that's uranium. And you can see the Colorado state line is this vertical dashed line. The green colors are Colorado readings, and the blue are Kansas. And so what you're seeing here is an increase in sulfate and an increase in uranium as the Arkansas River flows from the Rockies through the plains of Colorado and hits the Kansas line. And there's a high correlation between the sulfate and uranium. In other words, when you have a high sulfate, you're going to have high uranium. And it's a very nice correlation. So we can actually calculate from the continuous measurements of sulfate that we have at Coolidge, from the United States Geological Survey takes those. We can calculate the uranium passing across the state line. And we estimated, just for an example, that in 2017, 10 tons of uranium crossed the state line. Where'd that go? That went in to the aquifer. And you can see here on the lower plot, I've got the drinking water. That's a maximum contaminant level for uranium. And you can see that that has been exceeded. This is a problem that Lakin, for example, has had to deal with, because this water has gone into the aquifer and causing big problems for Lakin's water supply. And they had to put in that very expensive reverse osmosis plant as a result. Now, this is naturally derived, but it's naturally derived from groundwater reacting with the shales that are underlying the aquifer there in Colorado. It comes in, the uranium is brought into solution, and then it's concentrated due to evapotranspiration you've got shallow reservoirs. It gets used and reused for agriculture, irrigation, and so it gets concentrated. And it's concentrated 3 to 4 times above what it would be under natural conditions. And then it shows up in Kansas with these very high values. And then it moves in to our aquifer. there. It gets dumped into the aquifer there around the Lakin area. And we have this correlation, strong correlation between uranium and sulfate. I just wanted to illustrate it here. The circles, whether they're open or closed, those are river values or river quality, water quality samples that we and others have taken. The plus signs are irrigation wells. And I think all of these are north of the ARC and west of Garden City. And then you've got some readings, some values associated with the Lakin well field and some with the Garden City well field. Now, you can see we're getting some very high concentrations in some of these irrigation wells, and that's concern over time that we could have some problems for irrigated agriculture in this area. So I just wanted to draw the committee's attention to this, that we currently at the Kansas Survey, we're working with the Kansas Department of Health and Environment to really get a better feel for the distribution of this, I guess you would call it a plume, coming in from Colorado and threatening the long-term sustainability of irrigated agriculture there north of the river and west of Garden City. And I mean, this is going to be a long-term process because it moves slowly outward, but it's going to continue to move. So I just wanted to draw that to the committee's attention because it's certainly a concern. And I've got some additional slides following the presentation that have more details on this, but I just wanted to mention it in passing. So with that, I am going to just very quickly bring this to a close and open it up for questions. Just a few major points. Kansas Water Resources, think of them. Think of that. Remember that large decrease in annual precipitation from east to west. You get surface water mainly used in the east, groundwater in the west. The major aquifers, of course, we've got the high plains, and then we have these aquifers in the river valleys, of which the Kansas River alluvial aquifer is one of great future importance. Characteristic of Kansas aquifers, quantity. The water moves very slowly, 1 to 3 decades to go a mile. Because it's moving slowly, because it's moving through very small spaces where the friction is very high. So it keeps the rate low. We do not have underground rivers in Kansas. Second point about quantity, conservation-based reductions will reduce the rate of decline. And I think some of these programs with the producers getting together and figuring out what they can do, I think have a lot of potential. And in terms of one other issue with quantity is Kansas has some of the best water quantity data in the world. So we're fortunate to have this. And so the Kansas Survey, we're trying to mine this data to do as much as we can with this data. In terms of the characteristics of the aquifer quality-wise, quality is in general good in a regional sense. But there are some issues, and I've mentioned 2 here, the lower quality in portions of South Central Kansas, and obviously what I just talked about west of Garden City. And with that, that's all I wanted to present, and hopefully it wasn't too discombobulated, and I'd be happy to take any questions that the committee might have. Thank you.
Dr. Butler, that was a wonderful presentation, and for the new members in the legislature, we passed a joint resolution last year and sent it to our federal delegation to help with the uranium situation in southeast Kansas, or southwest Kansas, I'm sorry. And we'll have more information on that later. But for now, as expected, a lot of hands are going up. So with that, the first will be Representative Riley. Your question, please.
I'm not hearing any question.
None of us are. He's still muted. So let's move on to Representative Scottsdale.
Thank you, Mr. Chair. terrific presentation, very informative for somebody from eastern Kansas whose main contact with water is underneath their kayak. So I had a quick question about how are the water rights allocated in western Kansas with farms and so on? Is it by acreage? Is it by crop production? How is that? How does that work?
Well, I'm not the expert on water rights. I mean, that would be the Division of Water Resources. But in Kansas, we have, it's a first in time, first in right system. And so you set up, you apply for a right. I mean, most of these areas in Western Kansas are now closed for additional water rights simply because of the depletion situation. But I would defer before I mean, speaking to the legislature, I have to be very careful to make sure I don't misstate things. So I hesitate to say too much about the water right framework and encourage you to have a speaker from the Division of Water Resources because it can be quite involved is how I would characterize it.
Okay. Mr. Chair, I had one other quick question if I could.
Please do.
Yeah, I was just wondering on impacting the quality of water in the aquifers and stuff. Does fracking injection, does that have any impact on the water quality in the aquifers?
I don't think it has a much of an impact. You know, in Kansas, we've been fracking wells since 47. 1947 was one of the first vertically fracked wells around, I believe. And we haven't seen a lot of issues associated with fracking per se. I mean, the horizontal wells, they're now involving much larger volumes of water. But at this point in Kansas, we cannot point to many. I cannot think of an example. And now the Kansas Department of Health and Environment might know of a few. I mean, at the survey in the fracking issue, it's been more of the earthquakes associated with disposing of the salt water that's a byproduct of the oil production.
Okay. Thank you, Mr. Chair.
Chairman?
Who's speaking, please?
Bishop.
Go ahead.
Beg your pardon, but I have a question and I've been unable to figure out how to get recognized otherwise. My problem. Okay, I am unmuted. Thank you, sir. I appreciate it. I have a question about the Equisbeds Aquifer Recharge Project. I received a notice from our congressman that the Equisbeds Aquifer Recharge Project has just received a $1 million fund for construction needs. I'm just curious as to the reason for the recharge project, which takes water from alongside the Arkansas River, treats it, and re-injects it into the Equisbeds, if I've got that process described correctly, I hope. And part of the reason is to stave off the salt plume that is coming in from the northwest. And I believe it's successful. I would like some feedback on your impression of how it is working, whether it is working. A lot of effort and funding has been put into it. And then lastly, whether that sort of project has any relationship whatsoever to some of the problems along the Kansas River to the north, and as it goes into the Kansas City area. Since there is no need to keep back a pollution plume, maybe there is no relationship, but I just was wondering if you could reflect on that. Thank you, Mr. Chairman.
Well, I'll start off with the Equisbeds. I'm not an expert on all the details of that recharge project. My understanding, it's the Little Ark, which is a tributary to the Ark, which is being the source of much of that water that's being distributed there. I think it has been effective in staving off the salt water, and that salt water, again, well, it depends on, there are a couple sources of salt water there. There's the natural source, which is from this natural discharge of salt waters at depth into the aquifer. It goes into the river upstream of the equus beds, and then that can come in to the equus beds aquifer, and so trying to stave that off. And also there is pollution problems produced by old practices, and now I'm talking like the 20s and 30s, when they pumped oil and then they separated out the salt water from the oil, because 90% of the fluid coming out of petroleum wells in Kansas is salt water. So they separated that out, and now they inject that at depth. But at that point, they disposed of it in what's so-called evaporation pits on the land surface. And basically, those were recharge basins. And so that water, that highly saline brine, then went down into the equus beds aquifer. And so that's creating some problems as well. And so there's some challenges that they have there in the equus beds to stave off the saltwater contamination, both natural and man-made. But I think that recharge project is effective. It also helps the area in terms of being prepared for an extended period of dry conditions. I didn't mention this in my presentation, but in South Central Kansas, they are very fortunate to have periodic wet years and really wet years. And those years basically reset the aquifer, and you can start anew. So you may have drawn it down a fair amount, but then you get a really wet year and you can recover that. Now, if we start, for whatever reason, if those wet years become less frequent, then there's going to be more challenges there in the equus beds in Great Bend Prairie. So that recharge project could be very helpful in helping them store up water to be prepared for the future. So that's my equus beds answer. Let's go to the Kansas River. I don't think there's any real issue there per se in terms of that same level of saltwater contamination or anything like that in the Kansas River.
Okay, we have Representative Vaughn, please, with your question.
Chair, I just have a couple of questions, if that's okay.
You will have to speak up, please.
Can you hear me okay now? Okay. The first question, so on the slide you were talking about during years where there's increased rainfall, there's decreased pumping of the aquifers. I just wanted to clarify, is that because the precipitation is used for irrigation as opposed to the water re-entering the aquifer?
That is correct. They don't have to pump as much, so the crop water needs are being met by the precipitation.
Okay, and then follow up to that, and this may be a question for you, Mr. Chair. Are there ways to increase the collection and storage of rainfall to use in off years, for example, when there isn't as much precipitation?
We will be getting into some of the things, and we may have to have Dr. Butler come back and speak about some of the natural formations in the western part of the state that are theorized to be used for recharging the aquifer that have been farmed, and possibly if left alone, they may help. And I'll let him speak to that
Well, you know, I think the best hope in terms of having capturing excess water is to have these small dams on the ephemeral streams that exist in certainly in northwest Kansas. They can have small dams, water ponds behind that, and then that will infiltrate into the aquifer. And that has been shown. We have an index well close, very, very close to a small dam over an ephemeral stream channel. And you can see on those wet years that we do get recharge into the aquifer through that mechanism. But it'd be something along those lines would be the way of doing it.
Great. And then I just have one more question, if that's okay, Mr. Chair.
Please go ahead.
Okay. So during the presentation, you mentioned that a lot of these projections are under current climatic levels. And I'm wondering, as the climate continues to change, how these projections may change, if they would change.
Well, it depends on how the climate changes, and there's just uncertainty about what the future holds in terms of a warming climate. I mean, most would agree that it's going to get warmer in terms of the impact on precipitation and how that warming, is that mainly during the winter or is it also in the summer? So it's difficult for us to project. We do have means. If you make certain assumptions about what the future is going to be like, we can project into the future with those assumptions. But I hesitated to present that to the committee because of the uncertainty associated with it.
That's great. Thank you so much. I really enjoyed your presentation, Mr. Butler. Thank you.
Thank you.
Let's go back to Representative Riley. Are you still have a question or not?
Yes, I do. Thank you,
Okay.
Mr. Chair. I was trying not to get an echo on my phone here, but my question had to do with the picture that I see on my screen, or irrigation well and the amount of water that they're using. Is there any kind of impact numbers kept tracked on the ethanol processing plants like north of Wichita? There's several around, and they're using millions and millions of gallons of water for their processing. Is there some impact statements on what they're doing in comparison to wells? Thank you.
That's a good question. I'm not sure of the answer. I'm sure that we can find that out, but at this point, I don't have that data in front of me. I've not seen any impact statements associated with that. I mean, the irrigation is the major player when it comes to water use, groundwater use in Kansas. There's no doubt about it. But these other uses could be playing a role as well, but in terms of declines, but I think it's primarily the irrigation. But we certainly can get that information if that's something that you'd like to have.
Yes, thank you, Dr. Butler. I appreciate your presentation. I would like an example of how much water in 1 year does the average irrigation well use, so we can compare it against the average ethanol plant that's used. Thank you.
Okay, I'll do that.
Now I see Representative Haswood has a question. Please go ahead.
Thank you, Mr. Chairman. I have 3 questions, if I may.
Go ahead.
Great. Thank you so much, Dr. Butler. This was a great presentation. I just wanted to, I don't know if you already said it in your presentation, but the Ogallala, does it supply more water outside of Kansas and to other states?
Sure. I mean, the Ogallala is the High Plains Aquifer is a huge resource for many of the states over which it lies. Nebraska being probably the largest user. Texas is a major player as well. But all the states, I mean, Oklahoma, Panhandle, Colorado, they're all utilizing it.
Okay, thank you so much for the clarification. And you mentioned on slide 5 where we get about half a foot to a foot a day of the groundwater of the aquifer. Is that a normal rate?
That's I want to make sure that's the movement into the lateral movement of water. That's not a decline rate in the water. That's not a vertical decline rate. The vertical decline rate varies dramatically depending on where you are, but it'd be maybe a foot a year on average in Northwest Kansas, something like that. But in terms of the lateral, horizontal rate of flow, that's what I was trying to get at. That so it's a half a foot to a foot a day. Because you often hear people talk about underground rivers, so I just wanted to emphasize that's not what we have here in Kansas. Go to Kentucky for that, maybe Missouri, but not in Kansas.
Thank you so much for the clarification. And could you briefly tell me again on slide 2, you said Douglas County was under other, and what was that again? The reason?
Oh, that's the Bowersock Mill there at the bridge there. It's on both sides, and they've got the modern facility there on the north bank. But it's a non-consumptive use, where all these other uses are consumptive, like this irrigation. You put it on the plant uses a good portion of it for transpiration, industrial uses, but there it's just running through and driving the turbines.
All right. Thank you so much, Dr. Butler, and thank you so much, Chairman.
You're welcome. We have time for one more, and I see that Representative Minix has a question over on the chat side. Would you like to ask your question?
Thank you, Mr. Chairman. Dr. Butler, are the playa programs in Western Kansas effective for recharge of the aquifer? And I also had a question on the Wichita County Lima, as you showed it. I was under the understanding that it was a water conservation area. And could you talk about the differences between the two?
Okay, the playa question, that's a question that is folks are exploring currently. It's still open for further work before we can say anything definitive. Certainly, there's the hope that the playas could be playing an important role in recharge and could be a recharge source. But at this point, we can't really comment more than that. In terms of the Wichita County situation, initially they were talking a water conservation area. Then they went to a Lima. I was not involved in the details of all that. My colleague Brownie Wilson did testify and presented the results of some of our work, showing basically giving them an idea of what sort of response they would get for a certain level of water use reduction. In terms of the WCA, and again, this would be something the Division of Water Resources, I'll undoubtedly screw this up, so this is an approximate description, but the Limas require approval by the Groundwater Management District, is my understanding, whereas the WCAs do not require that, and a WCA could be done by a single individual, where he or she comes out with a plan that they're going to reduce their water use, and they sign some agreement, and it's their pumps are, their flow meters are checked, etc. Or there could be a few people getting together and saying, okay, the three of us are going to reduce water use by so much for the next 5 years or whatever. But it does not require the approval of the Groundwater Management District in which these areas reside. That is my approximate understanding, but I strongly encourage you to ask that question to someone who's more knowledgeable.
Thank you, Mr. Chairman.
Dr. Butler, we really, really appreciate this presentation. It is very informative. And for the committee, I would suggest that if you still have questions, please send them in to Damien, the committee assistant, so that we don't duplicate a bunch of the same questions. And we'll send them over and get a response and then send those out to the committee members. One other thing, if you're interested in the uranium situation, Representative Jennings lives in Lakin, Kansas. He's very familiar with it, and he can fill you in with a lot of detail. And as the good doctor said, it is moving eastward, and Garden City is in the target of that uranium plume that is moving eastward. So with that, thank you very much, committee. Tomorrow, I will not be in attendance. Unfortunately, I have an appointment that I cannot get out of. So the vice chair will be taking over, and it's going to be a good one. We're going to have an overview of water law presented by the professor at Washburn University. I look forward to it. I'll be listening to it as I'm driving. So with that, we are adjourned.
Meeting minutes?
Meeting minutes. Tomorrow, we will go through the minutes that you've been provided and approve those minutes. So be prepared to do that. Thank you, Damien. Anything else, Damien?
Not to my knowledge.
We're adjourned.